So in this problem, we're going to calculate first the gradient at 0 and 1. This is the function f of x and y, and it is defined as y to the fourth plus 2 times x times y to the third plus x squared times y squared. So the gradient would be partial f over partial x at the x component and partial f over partial y at the y component. So partial f over partial x would be just 2 times y to the third plus 2 times x times y squared. And the y component would be 4 times y to the third plus 6 times x times y to the second plus 2 times x squared times y. And we substitute in 0 and 1, we get, well, for the x component it is 2, and for the y component it is 4. And then in the second subproblem, we want to find out the directional derivative at the point 0 and 1. And this derivative is along the direction of 1 and 2. So this one should be quite straightforward. It is just the gradient of f at 0 and 1 times the vector, which is along the 1 and 2 direction. So that's, well, what it is. And then we're going to divide it with the absolute value of this vector, which is 1 and 2. So the gradient is 2 and 4, and the vector is 1 and 2. And the absolute value, well, the length of this vector would be square root of 5, because the square root of 1 plus 2 squared would be just square root of 5. So anyways, we see that it is just the inner product of 2 and 4 and 1 and 2 divided by square root of 5. So you can see that the inner product is just 2 times 1 plus 4 times 2, so it's just 10. So it is 10 divided by square root of 5. And it should be quite obvious that it is just 2 times square root of 5, and that is the final answer of this problem.